So let's separate all the x terms here. What do we have? X power n. When we take this common, we have only one thing, q of 1. Yeah, right. Plus x power n minus 1. What can we take common? q2 minus q1a, because you see this x power n minus 1 is here as well as here. So what do you get? X power n minus 2 times q3 minus q2a, and so on till x times qn minus qn minus 1a plus, what are the constant terms here? R minus qn a. Alright, because even here there's a constant term and this is a constant term, so these two things give us this. Right, so what was this? F of x. F of x is equal to all these things. So what was f of x originally? So f of x originally was this thing, right? So let's write it here. A naught into x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus so on up to a n minus 1 x plus a n. This thing is equal to q1 times x power n plus q2 minus q1a x power n minus 1 plus q3 minus q2a minus q2a times x power n minus 2, and so on till you get qn minus 1a times x plus r minus qna, or let me write this down, let me write this below. Plus r minus qna. Right, so when we compare the coefficients of like terms, that is when we compare the coefficients of x power n on both the sides, x power and then x power n minus 1, what do we get? We get a naught is equal to q1, right? And when we compare the coefficients of x power n minus 1, we get a1 is equal to q2 minus q1a, and a2, when we compare the coefficients of x power n minus 2, we get a2 is equal to q3 minus q2a, right? And so on till when we compare the equations of x power 1, an minus 1 is equal to an minus 1 is equal to qn minus 1 a, right? And when we compare the constant terms, what do we get? An is equal to r minus qn times a, right? So basically what did we wanted? We wanted to find the quotient, that is we wanted to find, first we defined it in this terms using q1 and q2. So now we want to find the values of this q1 and q2, right? So we've got some equations here. So let's define q1 q2 in terms of a and a1 and a2 and so on by these equations. So these are the 5 equations by which we can define the values of q. So by this we get q1 is equal to a naught, right? Now by this equation we get q2 is equal to a1 plus q1 times a. By this equation we get q3 is equal to a2 plus q2 times a. And by this equation what do we get? qn is equal to an minus 1 plus qn minus 1 a. And finally the remainder by this equation is r is equal to an plus qn times a. So you notice here that we are multiplying q2 and a, then we are adding it to a2, and we are doing the same step every time. So what do we see in honors method? What do we see in honors method is exactly the same thing. We draw two lines. If we are dividing it with x minus if we are dividing it with x minus a, then we write a here. We write the coefficient of f of x, that is a naught and a1, a2 and so on. And first we write a 0 here, so that when we add these two we get a naught, that is this a naught is nothing but the q1. That is the reason we add a 0 here. This is q1, and what we get in the second place is q2, what we get in the third place is q3. So by this equation we see that q1 is equal to a naught. That's why, and then we multiply these two, we multiply this, so we get here q1 times a. Now we add a1. See, by this equation you see the same thing. We add a1 to q1 times a, so that we get q2. Oops. So what I get here is q2, that is a1 plus q1 times a. So we see that here we are first multiplying and then we are adding. That is exactly the same thing we do, but in a different way. That is writing it in one below the other and then doing this. So I hope you all understood what's the reason we follow honors method, or what's the proof of this honors method. Hope you all got my point.